All right, students. Those of you who would like to see an example of finding the distance between 2 points, that's what I'm going to do. So we're going to say that we're given these 2 points, okay? So here we have maybe the point 3, comma, -4, and then the point 6, comma, 10. Okay, so we have these 2 points, and we need to find the distance between them, right? So we know that if we were to draw a graph of these 2 points, let's see here, we'd get something, and I'm just going to do this as an approximation. So we'll have over 3 and down 4, so we might have a point here, and then over 6 and up 10, so we might have a point here. And the question is, what's the distance between them? So I'm going to do a dotted line. We want to know what that distance is. Is it 12? Is it 5? What is it? Now, you can use Pythagorean theorem. We could make a triangle out of this, a right triangle. And then we can treat this distance as the hypotenuse, or C. And this could be distance A, and this could be distance B. And we could count these sides and find the diagonal. Using Pythagorean theorem, you can do that. Or some nice, kind person made a formula called the distance formula for 2 points. And that's what I'm going to give an example of today. So the distance formula looks like this. Okay. When you have 2 points, the first one is x1 and the second one is y1. And then in the next point, we call it x2, comma, y2. Just so that we can tell the difference between them, we have to put a little 1 and a little 2. Now the formula goes like this. D is equal to, and then a huge square root sign. We have the distance between, the difference between the x's, so x1 minus x2. And that thing has to all be squared. And then we add on the difference between the y's, so y1 minus y2. And that thing also has to be all squared. Okay, that's all goes under the square root symbol. So now let's plug in, and we'll use red to label. So this is going to be x1, and this is going to be x2, and this is y1, and this will be y2. Okay, so now we have all 4 of the values that we need to plug in. So our distance is going to equal, for this problem, big square root sign. And then for where there's an x1, I'm going to come up here and say, oh, that's actually 3 in this case, so 3. And then minus x2, which is 6. And that piece will have to all be squared. Then we get to add on the difference of the y's, so y1, which is -4, minus y2, which is 10. And that piece has to all be squared. Okay, now let's simplify this a bit. So our distance is going to equal, let's see, -3 squared, because 3 minus 6 gives us a -3, plus -4 minus 10 is a -14, all squared. Good. Dang, I'm thinking I should have made the problem a little easier because I don't know 14 squared off the top of my head. Now, since these negative signs get squared, when we rewrite this and simplify it further, the negative's inside of the parentheses, so that means we're going to have like a -3 times a -3. And we know that 2 negatives give us a positive, so this will just be a +9 here. And -14 squared, well, let's look and see what 14 squared is. This is going to be 16, 4, 5, put a 0, 4, 1, and it looks like we're going to get 196. So this will be adding a positive 196 because 2 negatives again make a positive. And I'm going to have to make a little bit of room here. Let's delete that. Oh, it won't let me delete it. That's okay. We've got enough room. So this is going to equal the square root of 9 plus 196 would be 205. You could put that in a calculator and get a decimal. It's going to be, what is the square root of 205? It's going to be let's see, it'll be in between 14 and 15, I believe. So it'll be pretty close there. So that would be the length. So this length here, C, is the square root of 205. Or you can put it in, like I said, and get a decimal. So that's an example of how we use the distance formula for you and where we plug things in. I hope it's helpful. If you have any questions, go ahead and send me an email, and I'll be happy to answer them. Thanks.